All right, so like I said, we did this one more practice quiz pretty much. Tomorrow, your quiz is going to be another one of these. Not going to give you any surprises. It's another of these exact same 5 questions. I'm going to change the numbers, and for tomorrow for the quiz, I'm going to put them in different orders. So this one was the same as what we did yesterday with just different numbers. I'm just going to rearrange them so you don't just get used to doing this first, then this, and then this, okay? But it's the same exact quiz or the same exact document. I'm just changing numbers and changing the order. I want to remind you, and this was on the board, but I'm going to erase it for tomorrow, the key words you're looking for. Anytime you see something about arrival, that is scrap paper. And when you see anything about travel, that means no scrap paper. So just use the reference table like a normal graph. So to start with, number 1 says difference in arrival. I gave you a time. So we do scrap paper stuff on the time side. Oh, I can't use that. So we do the scrap paper. We start out on the time, and I gave you a time of, oh, this is yesterday's. So hang on, didn't give you 4:20. Gave you a time of 6 minutes and 40 seconds. So you mark off the 0. Mark off 4:20. No, you don't. That was yesterday's. What is it? 6:40. And you slide it up till you find where it fits. And I do want you to be careful when you're trying to see where they fit. You do need to be as accurate as possible. I got 5,100 kilometers. Again, you could have as high as 200 higher or smaller there, as long as it's really as careful as you possibly can be. Now, the next one is a travel time. So how far can they travel? Remember, when we hear travel, that is not scrap paper. So we go to 5, and I give you a time. So that's 5 minutes and 50 seconds right there. Go over till you hit the line, read down for the P. I gave you 3,100. And for the S, I got about 1,500. Again, you could be up to 200 off. This time, again, we're talking about arrival. So we know in the end, we're going to have to do scrap paper stuff. But to start with, we need to subtract. So we take the 124.40 minus 120.25. This one is no borrowing required. 40 minus 25 is 15. 4 minus 0 is 4. Then you still have to go back and mark your 0 and 415. When you do that, I got 2,800. Again, for number 4, it's an arrival time one. So we know we need to do the scrap paper, mark off this. Now this time they gave us a distance. So we have to first find 4,400. Mark off the P, mark off the S, slide it over, see where they match up, and mine matches up perfectly at 6 minutes. And then number 5 is a travel, so no scrap paper required. Go to 3,500, go up till you hit the line, read over, you get 2 separate answers. For the P wave, I got 6 minutes and 20 seconds. And for the S wave, I got 11 minutes and 10 seconds. Are there any that you still need to go over? How are you feeling for the quiz tomorrow for the most part? Good. Probably way better than you were a couple days ago. Awesome. All right. Okay.
What ones are on 21 that need to be done?
The bottom left corner. Yep.
All right, thanks.
All right. So we are going to move on to something new today. So just knowing this stuff is not enough for knowing anything about earthquakes. This has to get combined with other information. So we're going to be going to page 27 of your packet. So if everybody could turn to page 27 of your packet. Page 27, please. So what we've been doing so far is making sure that you understand some of the, how long it takes P waves and S waves to get places. What I'm not sure if you've established is some of those questions, like the question 3 where we had to subtract. It said the P wave gets here at 120.25. The S wave gets here at 124.40. And it wants to know how far away the epicenter is. And we established that the epicenter was 2,800 kilometers away. That's how scientists actually find out where an earthquake happened. So what they have are these seismic recording stations set up around the country. They're little machines that can feel even the most minute P and even the most minute S wave. And they pick them up and then they do the math, the same math you guys have been doing, to figure out how far away the earthquake is. But if I had one of those seismic recording stations here and I did the math and I realized that the earthquake was 2,800 kilometers away, does that tell you where the earthquake is? So if I know it's 2,800 kilometers away, can you tell me the name of the city that it's in? Even if you were really good at naming cities, why not? Where is the earthquake if it's 2,800 kilometers from us?
You can be like any direction.
There you go. That's the key. It could be 2,800 kilometers to the north, the south, the east, the west, or anywhere in between. And that's the problem. And so what they do is called triangulation. And this again is on page 27 of your packet. Before we get to how scientists actually do it, I have like a simple example here, and that's what the reading is all about. So we're going to start with, are we there yet? On page 27. It says, imagine you don't know where you are. You ask the first person you see, who replies, you are 600 miles from Phoenix, Arizona. You find this odd, but you look at your map and come up with a number of possible locations. Okay, first question. How could you get a number of possible locations if you are 600 kilometers from Phoenix? How would... There you go. So that's the problem is we can go 600 kilometers, which I'm going to make a quick scale here. Oh, it's 600 miles, wasn't it? 600 miles. That's 500. The 600. So that means if this is 600 kilometers here, I could be here. Or here. 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 All of these places are 600 miles. I just moved, sorry. All of these places are 600 kilometers away from Phoenix. And they're not the only places that are 600 kilometers from Phoenix. What do you notice about what I just drew around Phoenix? It's basically a circle around Phoenix that had a radius of 600. Have you guys ever seen one of these thingies? No, you've never seen one that looks like this, right? You guys in math, not these exact ones, but you oh, not a measure and label compasses. That's not drawing. You've used ones that look more like this, right? These probably don't. These look like probably pretty junky versions of what you've used. But you know the general idea of how to use these. You put them down and you draw yourself a circle around Phoenix. So I know, you can barely see that here. Let me copy it out on here with, so this isn't going to be perfect. Everywhere on that circle is 600 kilometers from Phoenix. So knowing that one piece of information, is that enough to tell you where you are? No. So this person continues on page 27. You decide to ask another person. This person replies, you are 710 miles from St. Paul, Minnesota. Again, you find this strange, but you add this piece of information to your map. What do I need to do now? Okay, so now I got to go to St. Paul, Minnesota. And again, how far are we from St. Paul, Minnesota? 710. So let's see, where was I doing this? So again, if this is 500, this is 600, this will be 700. We're going a little bit further out. So here's 710 miles right there. And I need to find St. Paul, which is its own problem. St. Paul, Minnesota, there we go. And I draw myself another circle. And I would have. Okay, so again, here's my circle. And my circle's not perfect because I was just copying it here. Do we know where we are yet? We have an idea. Am I over here in California? Am I over here in Charleston? No, even though this place in California is 600 from Phoenix, and over here in Kentucky is 710 from St. Paul, Minnesota, there are only two places that are both. Right here and right here are the only places that are both 600 miles from Phoenix and 710 miles from St. Paul. What do we need to do now? Draw a third circle. We're gonna say ask another person. So we do that. So it's again, finally, you decide you need to ask one more person. The last person says you are 640 miles from Boise, Idaho. Aha, finally, we know where we are. So we got to do this one more time. So here again is 500. 600, 640 would be about halfway. Well, in this case, I don't think it's going to turn out to be a perfect city, but we'll find out. Denver is in there, yes, but it's not right on both of them. And I think that's actually, I think that's where it was supposed to come out, Boise, Idaho. Oh, so here's the problem. All right, so I draw this circle. Whoa. Yeah, and that's going to be the problem. So first of all, I'm using pretty crappy compasses. And I was doing it really fast. Did they meet perfectly? No, in theory, they're supposed to. In theory, they should all come together. But right about here, we've got 1, 2, 3. This general area is where they're trying to all come together. So yeah, we're around Denver somewhere. This is how earthquakes work. We can't tell where an earthquake is exactly from one set of numbers. You need to have all 3 sets of these numbers. It is also surprisingly how GPS works. So good old fashioned GPS that gets you places uses the same idea, except for instead of having just measurements, they actually use the satellites. And I think you guys know the general global positioning system, that's GPS. So there's a satellite revolving around Earth. And that satellite will bounce off your GPS and say, okay, this receiver, so we'd say Jonah's GPS is 1,000 or 10,000 kilometers from us. Then a different GPS will say, okay, Jonah is 8,000 kilometers from me. And then a third one will tell you Jonah's this far from me. And so they all work together simultaneously to send that information to your GPS and tell you where you are. In the past, we've done this whole activity and reading about this. I think for the sake of time, we do need to move on, and I'd like you guys to go to page 31. Yeah. So sorry, we're jumping around a little bit, but I just want to make sure that we get through this chapter before Christmas break. I think we've all had enough of earthquakes. So it starts off with locating an epicenter. So how many stations do we need to use to have to locate an epicenter? It says a minimum of blank seismic stations are needed to locate an earthquake. 3, we had to ask at least 3 people. GPS actually uses a lot more than 3, but as long as you have 3, you should be able to find exactly where you are. So if you could fill that in on page 31, we need a minimum of 3 seismic recording stations. What does it happen if we only have 1? What do we get? Okay, you do get a general area. You get a circle. So that's all you need to fill in there is a circle. So you get this circle around your city. And it actually will give you a lot. And I know this line is way too short. A lot of possible locations. Oh, okay. So that's why. It's all done for you? Just that, okay. So it gives you a circle and a lot of possible locations. 2 stations gives you how many? So when we had asked 2 people, we had narrowed it down to how many possible locations was it? 2. I'm a mess today. Okay, thank you. Oh my gosh. Pardon me. Huh?
Something's not like you over there.
No. Yeah, I'm going with it's probably just dirt and dusty up here, but no, I hate this. All right. So where you start to notice where these earthquakes are where the circles are starting to intersect. You guys know what intersect means, right?
Yeah, no, explain.
Don't make me. Okay, again, intersect means touch. How many, when we have blank seismic stations, how many? When we have 3, the epicenter is where they all meet, intersect, touch, whatever. So that is how earthquakes will really be used to identify where earthquake epicenter actually is. let's get the notes here for shadow zone. Oh, no, I'm sorry. We still have this. So here is an example. Seismologists will make something that looks like this. They'll draw those 3 circles. Theirs actually worked, unlike mine that I was drawing. It says a seismic station. Which seismic station is closest to the epicenter? So is it A, B, or C? Which one's closest? A. Now you guys did that pretty good, but how could you tell really quickly by looking at this? What about it? Yes, it's the smallest circle. So the smallest circle is the one that's going to be closest. So then which one's furthest away? B, which is the biggest. And then describe where the epicenter is. How could we put that in words? Where they meet. So describe where the epicenter is, where all 3 circles meet. And then it did go ask you to put an X there. Now, like mine did at the beginning of class, if they don't perfectly line up, which they probably won't for us, because we are not experts, and we're going to be using really crummy circle makers, compasses. If they don't touch perfectly, you will, I like circle makers better. If they don't touch perfectly like mine did, you do have to estimate by trying to see where all 3 are trying to touch. We're going to be practicing this in lab and a little bit in class. We have one more thing about earthquakes to learn tomorrow after the quiz, and then we'll just be doing some practicing. No homework again tonight. I've been really lazy with you guys with homework. Oh, okay. I thought you might.